You are.
Don't say anything.
Okay, this is going to start our exponent laws. So the first law we're going to do is multiplication rule.
Multiply.
Okay. So let's do this example a long way, and then we'll talk about the rule shortcut. So what would this look like expanded?
2 times 2 times 2 times 2 times 2.
2 times 2 times 2. Then
2 times 2.
you have this one expanded, which is 2 times 2. Yeah.
When you're marking these, do you want the 2 times 2 times, or the 2 times 2 times 2? Do you want that right under the equation, or can you put it off to the side as early?
That's fine too, yeah.
And then just put the answer. Yeah. Okay.
Yeah. Okay, so when we talk about powers, we have base and exponents. So remember what the base was. The base is what you're repeating, and the exponent is how many times you're repeating it. So what am I repeating? 2. How many times did I repeat it altogether now?
5.
5. Can you make a rule? What is a rule about this? Was that Annika? What did you say? Add the exponents. That is the rule. Okay, so when you multiply with the same base, so they have to have the same base, so this had a base of 2 and this had a base of 2, then you add the exponents. Sorry, it's not even on the screen. When you have this multiply, when you multiply, you add the exponents. Do you see why? I just showed you the long way. That's the reason why it's happening. Okay, everybody has a sheet that I gave them to recap. You won't get this on the test, but it's a good little study sheet.
I didn't get that.
Everybody should have one.
I didn't get it. Behind.
It's all in your stack of stuff.
Yeah, don't. Your stack.
Everybody should have that sheet. There it is. I see yours.
Which one? Oh, it's white on there.
Just exponent laws. It's just one paper. I gave everybody a one paper exponent laws. So on here, multiplying powers, it gives you an example. So it shows you to add the exponents.
Are you going to add the exponents?
Okay? So this is a sheet you can have with you doing your homework, but on your test you wouldn't have it. Okay, here we go. This one, do they have the same base?
Yep.
What is the base?
-3.
-3. Should I put that in brackets or does it matter?
It matters.
It matters. That -3, how many times would you repeat it at the very end?
7.
7. Okay, it says to evaluate as well. So we better go back here. It says evaluate. So that word in math means like get me that answer, give me the number. So evaluate. We're going to do this one without our calculator and we'll do this one with our calculator.
It's 36, right?
I'm very close to 36. So let's go back here. 2 times 2, what are we up to? 4. Another 2. 8. Another 16. 32. That's close.
You go like the exponents first, so you go 2.
Never don't do
or
it.
2 cubed. Yeah, would that be cubed? Yeah.
2 cubed is 8.
Which is 8, and then you just write your answer down and then times it by 2 squared, which is 4. Can you just do that?
Yes. Okay. This one we're going to evaluate. I'm going to let you try that one on your calculator. So are brackets important in your calculator?
Yes.
Yes. They are. So lots of you had
I bet you don't know what it is. It's that. What? Oh, sorry.
These are the 3 buttons I think are on the calculator. Some of you have this one. Some of you have just that one, right?
Oh.
Some of you have a button that looks like this, I noticed as well. But everybody knows their button out of those 3 options? Okay, would you have already guessed if it was positive or negative?
Yes, because there's an odd number of negatives.
Odd number of negatives. So I already know this is negative, and did you work it out in your calculator like so?
Yes, I did.
Woo.
I worked it out in my head, actually.
No, you did not.
Buddy, yes, what you talking about? I used my brain to push the buttons, and then the calculator gave me the answer. I worked it out with my brain.
Okay, next section. So showing me you know, I want you to write it out repeated multiplication. So what does repeated multiplication mean? I want you to write it like this. And exponent law, what does that mean? I want you to write it like this, 2 to the 5th at the end. So I need you to see this and this. You do not, it says to evaluate in 2 different ways, so get me the evaluation at the very end. So get me a repetition, get me the law, and evaluate.
Evaluate.
And I would let you do your calculator
Bad.
on both of them.
Hot bad. Yeah. Okay, bro. Oh, that's not me. Yes, it was. Why do you like? You know what? On my uniform. Yep.
Square. For 3, use question.
Oh my God.
Squaring whenever you square it. Yeah, it's almost, make sure we go. Yeah, just make sure. Yeah.
Carter, I won't be at youth on Friday.
Yeah.
What? Do you have the sharpener?
This is on
No, just look at that.
Friday. DNA? No. Tomorrow there's a food drive where you're It's fun. We basically drive around like 3 streets and then we go have like a big party set.
Okay, so
We're meeting at the sounds fun.
this is my expanded. I did repeated 3 times and 5 times. So I would have repeated it. Did you write 8 times? And I added the 3 plus the 5. That's how I got there. And then in your evaluation, 65,536.
65,536.
So again, I let you do that one in your calculator. Okay, the next one you should have expanded like so.
Oh, I forgot to do that one. Whoops.
Then at the very end, in the exponent law, the base is -5. So I put a bracket on that. And I ended up repeating it 5 times because there was 2 and 3 more I added. This should be a negative value.
No, I'll tell you what. What is this with this underguard? Just being Irish.
Okay, let's go to dividing. So that was multiplying.
I'm not there yet.
Okay, we are going to expand this out. So 2 to the 6. 1, 2, 3, 4, 5, 6. Divided by, so this is what it looks like when I expand it out. Does that make sense? Expanded, expanded. Okay. Do you know that this can happen in math? If you have a top 2 divided by a bottom 2,
Yes.
they can cancel each other to make 1, essentially, right? What's 2 divided by 2? 1. So I can just kind of scratch it off, right? Cancel it. I can also do that again here and here. You can only do it with division. You can't do it beside each other because they don't multiply to 1. 2 divided by 2 is 1. And what am I left with?
2 times 2 times 2
2 repeated
to the power of 4.
4 times. That's what I'm, and then if we evaluate it, do we know that one with our brain, not our calculator? 16. 4, another 2 is 8, another 2 is 16. Okay, what do we think about a rule? Yes, dividing with same base. You have to have that same base. With dividing with the same base, then you subtract exponents. So this I showed you was the y. Why are you subtracting the exponents? Well, you're canceling away, you're getting rid of them. Okay, so this is the second rule on your page. Division, you can see here what I did. Subtract. Okay, so this one, well, what's the base? -5 brackets. How many times would I repeat it after the rule?
15.
3.
I got that one.
Because you have to do what rule?
Take away the
Minus the exponents.
subtract
Okay, we can also do this one in our brain as an evaluation.
A equals.
What's the positive or negative? Negative.
Negative 75.
Urgent? Oh.
75.
Okay, what's 5 times 5? What am I up to? 25. Think about a quarter of money. Another 5. What if you have 5 quarters?
75. Like I said, 125. Like I said.
5 quarters, right? Okay. That was your division rule. Okay, so this is almost the same question. Okay, repeated multiplication is what the first thing says. So 2 to the 5th. Repeat that out 5 times. And divide by. So repeat 4 times. Oh, yeah.
You did say on the last page you could just subtract the 5 and the 4, right?
Yeah.
Like, yeah, okay.
Okay, so cancel, cancel, 1 pair. They have to pair out. You can't just cancel random. You have to make a pair. I can do this pair, another pair. I can do another pair and another pair. So let's talk about the law. The base was 2. And then the rule says to subtract. So 5 subtract 4 is 1. And I would never write that 2 to the 1. You probably will never see a 1 exponent because what does it imply?
The same.
Just the same itself. And you can see here, what was I left with? Just a 2. Okay. Oh, this one might take a while to write. Let's see how fast we can go. 10 times. You gonna run out of space? 1, 2, 3, 4, 5, 6, 7, 8. Oh, and a big one on the bottom too.
I love writing these numbers. Crazy knows where it's at. 6, 7, 8, 9, 10, bracket, 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 1, 2, 3, 4, 5, 6, 7, 8, bracket, line. -3. Carter, reading. One, two, three, four, five, 6, 7, bracket, bracket.
Okay. So this is what it looks like. Repeated 10 times, big across the top. Repeated 7 times across the top. Could you cancel partners?
Yes.
Boom. 2, 3, 4, 5, 6. There should be 7 partners on the division. And I'm left with it repeated base of -3 repeated
Twice.
3 times. What's the rule? Let's check the rule. What's the exponent subtraction? What's 10 minus 7? 3. Okay, we are going to do this with our brain power too. Evaluate.
-27.
-27.
Told you.
Odd amount of negatives.
Yeah, but you didn't see the right number because the right number is
Okay, we are going to go through 2 more rules. So now we did multiply and divide. So this one is raising a power to an exponent. Okay, so this says what is, okay, our noise volume, it's hard to talk over, 2 cubed raised to the second power. Okay, so this is raising a power to an exponent. Okay, what is the base? No.
2 cubed.
2 cubed is the base. How many times do you repeat it?
Twice. 2 cubed equals.
So this is what it looks like. 2 cubed gets repeated twice. Okay, now what is, if I just look at this, what is the base? Now this is just a base of 2.
Oh, yeah.
So I'm going to go 2 times 2 times 2,
Yeah, which is 8.
which is 8. Yep.
Yeah, that's what I meant.
So 2 times 2 times 2. So at the end of this, how many times did you repeat?
6.
6 times.
That's it. No, Carter, that's it.
Okay, does anybody want to think of a rule? So how did I get 2 to the 6th of that?
Multiply.
Now you multiply.
Wait, how did you get? No, I jumped on the
Okay, so power to an exponent, you multiply. Okay, so here's the rule. So you can see here, I'm multiplying the exponents. Okay, so this sheet shows you them all. So when you have a power to an exponent, you multiply. Evaluate. So you can do these like separate and times them if you wanted to. So Easton said that this value was 8. and this was 8. So you can say that that is 64. You could also think of this. We knew we were at 8, 16, 32. Another double would be 64. Okay, question B, I'm going to show you 2 different ways to do it. Okay, this would be the way I would personally do it because BEDMAS, bless you, tells me to do multiply brackets. That would have to come before the exponent. So what is the bracket worth?
2 times -3.
Which is -6.
Yeah, -6. Yeah.
Then to the 4th. Okay, I'll let you go to your calculator for that. Give me the...
Can I just like guess?
Yep, what's your guess?
256. 254.
Way bigger.
Way bigger. 386.
Let me guess, 1,297.
Wow.
Okay, one more guess.
Guys, I'm gonna guess
wow,
this
under
right.
two.
Brain power.
What
the heck is this?
Okay,
What is?
I'm now going to show you another way because this is the way it tells us to do. Write it as a product of 2 powers. Okay, so we are going to separate them as 2 powers. So the first power is going to be 2 to the 4th times a -3 to the 4th. Do you see what I did? 2 to the 4th and the -3 to the 4th, and then I'm going to times them. So do you guys understand what the instructions were? What does the word product mean?
Add. Or like the...
A product means to do what operation? Multiply.
Oh my bad.
What is the word for add? Sum. Yeah. And what does the word of 2 powers mean? They need to have a base exponent. A base exponent, a base exponent, a product. Okay, and 2 to the 4th, we've already done this a few times, that's 16 times, positive or negative here?
Positive.
Positive, that should be 81. What does 16 times 81 make in your calculator?
1,000.
1,200.
Oh, Carter. Guys, you didn't even have to do it in your calculator because it's right already on the paper.
Okay. So this one, write as a quotient of 2 powers. So what does the word quotient mean? Division. So I have to divide a power and another power. So this would be what on the top? 3 cubed. And the bottom would be 4 cubed.
So that would equal.
That would equal...
Well, we got this 2 cubes we got in our brain.
Oh, we could just do
27
27.
and 64. Okay, just for the fun of it, do you want to do this in your calculator for me? Brackets 3 divided by 4 to the 3rd power.
brackets 3. No, quarter. Stop. I can do it for quarter.
So 3/4
0.42.
repeated 3 times is 0.42 ... Can you go back and divide these numbers? What is 27 divided by 64? Same thing. Actually, can I show you something? Because I actually just discovered this a few years ago. This is a game changer for people. Okay, look at me on my calculator. I got 3 divided by 4 to the cube. Okay, and it equaled, you had a decimal. Did you know that you have a button that can change that to a fraction?
What? Really? I've
So
never been
right
able to
here
find
I have this button that's like A and then B over C. If I push it, guess what happens? 27 over 64.
it. No way. Hold on.
If I push it again, it goes back to a decimal.
I can press
I
this.
can't tell if you're acting shocked or you're just like genuinely. No, I'm actually like. I've had this calculator since grade 7 and I've never.
Maybe I shouldn't have shown you that till like grade 11 or
Where's
something.
the other boy?
Mine looks like this.
Oh my gosh. I have the same one, so it's super.
Can't find it? Okay, I'll come over later and I'll see if I can find
Have you
yours.
figured how to turn it off yet?
Okay.
Turn my calculator off?
Yeah, so basically you press the second F button, and then you press the on button, and it
Yeah.
turns off.
Yeah.
I figured that out like 2 weeks ago.
Okay, here we go. So, oh, we just did these.
Yeah.
That was one we just did. Okay,
This was the change button called.
let's write this in two different ways. Here we go. Two different ways. So the first way,
The bed mass one?
no, we just did that.
Oh, they're the same.
Yeah, it was the same question. I guess I went too far on the other side. Okay, this one. What is the base? -3. How many times would you repeat it with the rule?
4-dimensional and then cube.
So 4 and then cubed makes a whole exponent of
7. Oh.
12.
Yeah.
Remember the rule? If there's an exponent to another exponent yet, we have to multiply. Okay, what's another way I could write this? What is, and I could figure this out first, what is -3 to the 4th?
27.
81. You got to go another one.
Like I said, 27.
81. And then I would still have to cube it. Because I just did that to be 81, and then the 81 would still have to get cubed. Should these be the same number in our calculator? Yes. These should be equal to each other because it is the same question. We just wrote it in two different ways. So here I did the exponents, and here I evaluated the inside before the exponent. Okay, can you give me a type on this? Calculator stuff. What do you get? It might be big.
What did you do? 531,400.
531,400 and something, I think.
No, let me guess here. 531,444.
I did that.
531,400.
Stop.
Crazy at this.
The exact answer is 500,000.
And look at that. I got mine to match.
What if one of them equals 1 and the other equals 2?
Then you did something wrong.
Okay.
Okay, a couple more of these, and then we got one more rule. Okay, write in two different ways. So the first way would be, what if I did the bracket first? What do you get in the bracket? 20 and then squared. You can do this. What's 2 times 2? 400. You need 2 zeros on it because if you have a 0 and another 0, it will make 2 zeros. Okay? What's another way I could write it as a product of 2 powers? What's the way to write it as a product of 2 powers?
Oh.
So timesing, what are 5 squared? Yep, times 4 squared. What is 5 squared? 25. 25 times 16
Equals 400.
equals 400. Same thing, look at that.
That's insane.
So this question asked for that way, but I'm trying to show you that there's another way also to do it, right? And C says write it as a quotient of 2 powers. So I would have 2 to the 5th on the top, and on the bottom 5 to a 5th. So 32 over, that one's getting a little big.
3,125.
Okay, do you see, because this is a bracket, this repetition applies to the 2 and to the 5. If I wrote this, it only applies on the 2. So this would be just that. Do you see a difference? Yeah, we have one more rule.
Oh, we're not doing workbook. We have to. What's
One more rule.
times 6? But then we'll have a whole class of work, right?
Oh, this one won't take long. What is anything to the 0?
0.
No.
No, we go to 3.
No.
Nothing. Oh wait. Nothing. 3.
1.
Oh, Coke. Okay.
That's it.
So easy. That's so crazy.
Why?
Cocoa.
Okay.
I actually didn't know.
I'm going to explain to you why it happens. Let's see if it clicks in your brain. I'm going to give an example like this. Okay, here's just a random example. Okay, what do you get when you apply the rules? What's the rules with division? I have to do what to the exponents? If you divide, what's the rule? If you divide, you subtract the exponents. So what is this? 3 to the?
27.
3 to the 0. What do you get when you subtract the exponents?
0.
0. Okay. Now I have a question for you. What's anything divided by itself? Because that's what this is.
1.
That's why it happens. Do you see it?
Not for every case it will be like that.
Anything to the 0.
Whoa.
1.
That's so cool.
Okay, so prove it. So you can use another example like I had. -2, how many times do you want to repeat it? 2, okay. Which,
That's your fault.
so this is me proving it. So if I pick anything, -2 squared divided by -2 squared,
Equals 2 over 0. 2 to the power 0, which equals 1.
so what happens with division rules? What do you do with division? You subtract. That's the rule. And what in math happens when you do the same thing divided by the same thing? You get 1. Therefore, this has to equal 1.
So that equals 1.
Okay, so here you go. Last little section. I got 30 seconds left. What's the answer to A? 1. What's the answer for B? -1. Because the negative, is it involved in the exponents or is it after? After. What's C? -1. It's not applying. And 1.
Okay, workbook time. Let's move. What? Workbook time. Let's